Welcome, Precalculus. So these are going to be a continuation of the notes from 7.1 and 7.2, which is just systems of equations. We are going to be talking today about nonlinear systems of equations. And please excuse the weird notes that I have. Yours are normal. I just like changed the questions last minute on my side. So yours are fine and you don't need to make any changes. Anyways, back to the notes. So a nonlinear system of equations is a system in which one or more equations is not linear. So a circle, an ellipse, a parabola, something like that. It can be with a linear, it cannot be with a linear. And then with nonlinear systems of equations, there can be one solution, multiple solutions, no real solutions, or infinitely many solutions to a system of nonlinear equations. So typically with nonlinear systems of equations, we use substitution to solve for these. So that's really the method I'm going to be focusing on today. That's not saying that elimination is something you can't do. It's just that typically elimination is something you don't use with it because it's harder to kind of get all of the variables lined up. So we are going to start with the first one. My pen just exploded, so hopefully it works. Okay, so the first one is y equals x squared plus x minus 2 and x plus y equals 1. So I kind of look to see where is it easy for me to isolate one of the variables. And to me, isolating one of the variables, especially with y, I could isolate x, but then I'd have to plug it in here and here. So I'm going to isolate y. And so what I'm going to do, that means that I am going to get y all by itself. And so I am going to basically just write a new equation for this. So this is going to be y equals negative x plus 1. Okay, so now that y is all by itself, what I'm going to do is I am going to substitute that in to the equation above. So I'm going to plug in negative x plus 1 in for y up here. So I'm going to plug that in there. Okay, so I'm going to write that. So in for y, we're going to plug in negative x plus 1. And then we're going to set that equal to the rest of it, x squared plus x minus 2. Okay, now we know whenever we have a quadratic means x squared, or basically really anything higher than a quadratic. So whenever you have a variable on x or an exponent on x, you want to move everything over and solve by quadratic formula, factoring, one of those. So we want to here move everything to one side so you can solve by factoring or the quadratic formula, but let's just try factoring first, which it's going to work. So what I'm going to do, I always want to get my x squared to be positive. So I'm going to move over the x and the plus 1. So I'm going to add x to both sides, and I'm going to subtract 1 from both sides. And that's going to get me x squared plus 2x minus 3 equals 0. And now I can factor that. So I'm thinking what two numbers, I'm just using my x, what two numbers multiply together to get me negative 3 and add to get me 2. And that would be 3 and negative 1. Because a is equal to 1, I can just use the shortcut. I can go x plus 3, x minus 1. And now I can get 2 of my x values. So I get x plus 3 equals 0, x minus 1 equals 0, and I get x equals negative 3 and x equals 1. What this tells me is that there are two solutions for this system of equations. And remember, a solution is a point where the graphs intersect. So that means that this graph intersects at two different places. And I'll look at the graph in a second. So what we're going to do is we're going to plug in -3 and we're going to plug in 1 to get two different ordered pairs. So I'm going to plug in -3 first. So y equals -3 plus 1. So that negative and negative are going to cancel to get me y equals 3 plus 1, which is 4. And then I'm going to plug it in again. Y equals -1 plus 1. -1 plus 1 gets me 0. So I have my two solutions. My solutions are -3, 4 and 1, 0. So again, that means that this graph, when I graph these, which I'm going to show you the graph, they intersect at two different points. And so when I graph that, let's look. So we have y equals x squared plus x minus 2. And then x plus y equals 1. And so if we look, my line is cutting that parabola at -3, 4 and at 1, 0. So the 2 points of intersection there, which is why I have two solutions. And there we have it. So that is my first example. So really with systems of equations, like it says above, with nonlinear systems of equations, you can have one solution. You can have more than one solution, and you'll have no real solutions as well. You can have infinitely many solutions. Infinitely many solutions is pretty rare. You'd have to have the same exact equation, just like you do with lines. And that's typically not something that you see. So you're really going to see one, multiple, or no real solutions. And we'll have examples of all of those on this one. Okay, so if you guys are feeling comfortable with one, I want you guys to try two on your own. So I want you guys to go ahead and pause this video and try two, and then come back and check your work. I'm going to still walk you through two, so if you need to fast forward through it, that's fine. But try it on your own, and then come back and check your work. Okay, you should have come back, you have tried it on your own, and now you're just checking to make sure you did it correctly. Now this one's pretty straightforward because y is already solved for both of these. So what I'm just going to end up doing is I'm going to plug in this into here. And really it doesn't matter, you should get the same thing. And so in for y, I'm going to plug in x squared plus 3x minus 5 equals 2x squared plus 5x minus 4. And so just like I was over here, if I have an x squared, anytime I have basically an x with a higher exponent than 1, I'm moving everything to one side and solving by factoring or quadratic formula. So I look and see that this is the bigger x squared. 2x squared is bigger than 1x squared. And so I'm going to move everything over there. So subtract x squared. I'm just going to do this all in one step. Subtract 3x. Add 5. So I'm just combining the like terms on each side. And really, this is one that you could do elimination on. Honestly, I try and just typically do substitution with these, but it is definitely something you could do elimination on by multiplying this one by -1 and then adding, which is essentially what we're going to be doing here, right? So we have x squared plus 2x plus 1 equals 0. And now I can go ahead and factor that. Remember, these canceled. And so 2x squared minus x squared is x squared. 5 minus 3 is 2. And -4 plus 1 or plus 5 is 1. And so again, I'm thinking what two numbers multiply together to get me 1 and add to get me 2. And those are 1 and 1. And so when I factor it to be x plus 1 and x plus 1, which is the same factor. So when I take that, I don't have to get both of those because really I'm going to get the same x value. And so I have one x value. And that one x value, now I can plug it into either one. It doesn't matter which equation I plug it into. You should get the same thing. Great way to check your work. And so I'm going to plug it in. Y equals -1 squared plus 3 times -1 minus 5. I'm just going to use my calculator for that. So -1 squared plus 3 times -1. Notice when I put it in my calculator, I am putting the -1 in parentheses, and then minus 5, and that gets me -7. And so my solution is -1, -7. Now, I didn't say this on this one, but an easy way for you to check yourself is just now plug in -1 into this one to -1 squared plus 5 -1 minus 4, and I should get -7, which I do. So it's just a quick way. Same with here. You should be able to plug in -3 into this equation also and get 4, and then plug 1 into this equation and get 0. So it should work out for both equations for your original ones. Okay, let's move on to 3. So 3, and actually before we move on, let's double check and look at the graph here. So the graph, those are two parabolas, right? So we have y equals x squared plus 3x minus 5. And then we have y equals 2x squared plus 5x minus 4. And so I feel like, what did I do? I realized what I had done. I had typed in x equals, which had made it super wonky. So I double checked it. And so now we look at our two parabolas. Notice they intersect at one spot, -1, -7. And if I were to zoom out, they're never actually going to cross again. And so they only intersect at that one point. Okay, so let's move on to 3. So with 3, again, substitution is definitely something I would use with this one. Elimination would really not be something that would make it easier. So what I would do is really both of these are going to be the same. So really what I'm going to do is I'm just going to get y by itself. So I am going to rewrite this equation as y equals x plus 5. And then in for y into my second equation, I'm going to plug in x plus 5. So I'm going to substitute that in. And so it's going to be x squared stays as is plus, and then in place of y, we write x plus 5 squared equals 4. Now be careful with that x plus 5 squared. With this, we need to expand and multiply. And so what that means is I need to do x squared plus, and I need to expand that out, x plus 5 times x plus 5 equals 4. And then I need to multiply that together. So x plus 5 times x plus 5, I'm just right now going to ignore this. And that's going to be x squared plus 5x, so plus 10x plus 25 equals 4. Now, I don't really need the parentheses there because it's adding. But if there was like a 2 in front or a 3 in front, you'd want to multiply it out first and then you can distribute. But because it's just really plus 1, we're not going to do anything. So it's just x squared plus 10x plus 25 equals 4. So I'm just going to combine my like terms. X squared plus x squared is 2x squared. And then because it's a quadratic, I'm going to move everything to one side. So I'm going to subtract the 4 from both sides. And I get 2x squared plus 10x plus 21 equals 0. Now, you could try and factor this. It's not something that's factorable. Or you could go straight into the quadratic formula. Remember the quadratic formula. I know, sorry, my notes are super weird. Remember the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to use that to plug this in. If you were thinking, how would I think about factoring it? Remember, you'd be thinking what two numbers multiply together to get me 42, 2 times 21. and add to get me 10. The closest I got was 7 times 6, and 7 plus 6 gets me 13. There's really nothing else that's going to get me something less than that. So that's why this does not work. So we're going to use the quadratic formula. X equals the opposite of b, so negative 10, plus or minus the square root of 10 squared minus 4ac all over 2a. So I'm just going to plug that inside part into my calculator. So 10 squared minus 4 times 2 times 21, 2 times, and I get a negative. And so what that means is it's an imaginary solution. And remember, a system or solution to a system of equations is the point of intersection. So if it's an imaginary solution, that means it's not on the graph, which means that there are no solutions. It's never going to intersect. No solutions. And again, that means the two graphs will never intersect. Now, again, we can look at our graphs and see what those look like. So if I were to put that in decimals, that would be y minus x equals 5. So that's a line. And then x squared plus y squared equals 4. That's a circle. And so if you look, my circle's there, my line's above it, they're never going to cross, which is why we have no solution. Okay, fourth one, if you guys want to try it on your own, you can. There's more than one solution to this one. But if you want to wait and just have me walk you through it, that's fine too. But if you want to try it, pause now and then come back and check your work. Okay, so you should be coming back. Or you're just going to do it with me. So let's do 4. So on 4, just going to move it up a little. There we go. Okay, so on 4, I am looking like this one would be harder to get like one of the variables. This is just super easy to get one of the variables isolated. So I'm going to use this one. And I'm actually thinking like, yes, I can get y or get x by itself, but I'd have to substitute it in here and here. So I'm just going to get y by itself. So I only have to substitute it in once. And really, it's just y equals negative x. There's nothing else. And so in for y, I'm going to plug in negative x. So that's going to be x cubed minus 5x minus, and then negative x equals 0. Now that negative and that negative become a positive. So I have x cubed minus 5x plus x, which gets me x cubed minus 4x equals 0. Now everything is on one side of the equation. Now I'm going to solve by factoring. I'm thinking first, okay, it's not a quadratic, so I'm hoping that there's a GCF, which hopefully you recognize that there's a GCF of x. And so then I have x squared minus 4. And then with this one, x squared minus 4 is a difference of squares. X squared is a perfect square, 4 is a perfect square, and they're subtracting. So I have x plus 2, x minus 2, and then I can set each factor equal to 0. Now in this case, I'm getting 3 different x's, which means I'm going to have 3 different solutions. And so I'm going to plug those in. So y would be negative 0, which just gets me y equals 0. Y would be negative 2, which gets me y equals 2. And then y equals negative 2, which gets me y equals negative 2. So my solutions, you've got to be very careful when you're matching. Like your x's, you have to write them as ordered pairs, and then you have to match the correct x with the correct y because they're a specific point where they're intersecting. So this one, my solutions are 0, 0, 0, 0, negative 2, comma 2, negative 2, comma 2, and then 2, negative 2. And so that is important. You're matching the 0 with the 0. You're matching with the negative 2 with the 2 and the 2 with the negative 2. So if I were to graph this on Desmos, so that would be x cubed minus 5x minus y equals 0. And then y plus x equals 0. We can see that if the glare wasn't there, there we go, that there are negative 2, 2, there, 0, 0, and at 2, negative 2. So all of our solutions that we found, those specific points, which is why it's important to have the 0 match with the y, and that is it. So that's the notes for 7.1 and 7.2. So we are done with that. Make sure these are glued into your spiral, and that is it for these notes.